And I'm going to make a promise that today's lesson won't be as long as last week's lesson, last Thursday's lesson. So, we got that going for us today. So today we're going to talk about conditional probability, which basically is the probability of one event happening after another event has already happened. So most often, conditional probabilities are calculated using tables of data rather than just kind of a description. We won't say, well, you roll a die and you get a 2. What's the probability that you roll a 7? That's not what we're going to do. Although you could certainly calculate that. Most of our problems, and I think all of them actually, deal with data that's in a table, and that makes it a little bit easier to work with for these conditional probabilities. So a conditional probability is a probability that event B will occur given that another event A already occurred. And you have a kind of a description that's used if you have a table of data, and then underneath it, I will show you a formula that's used just kind of in general, the way that it's written. So the general formula is the probability of B given A. So that's the way that this is read. The probability that B happens given that A has happened is equal to the probability that both A and B happen divided by the probability that A happens. All right, let's take a look at a few examples. A student committee is being formed to decide how after-school activities will be funded. The committee members are selected at random from current club members. The frequency table shows current club membership data. So the drama club has 3 sophomores. The science club has 9 sophomores. The art club has 24 sophomores, for a total of 36 sophomores in the Monday club membership, and so on. Juniors have 6 members in drama, 18 members in the science club, 16 members in the art club, for a total of 40 juniors in the clubs. Seniors, 8 in drama, 13 in science, 18 in art, 39 total. One of the things that I want to make clear, this total amount is the sum of either the total column or the total row. It is not the sum of both. So you could check 36 and 40, that's 76, plus 39 would be 115. If I add both, I would get 230, and that's not how many students are involved. It's just 115 students. So just be careful about that total column. So the first question, what is the probability that a junior is selected? Now, this is not a conditional probability. This is just a straight forward probability. So how many total students do we have? Iman, that's actually going to be the next question that I ask. But go ahead, Shane. Oh, go ahead.
115.
115. Right. There we go. And of those 115, as Iman chatted to me, 40 would be juniors. And then I should reduce if I can. Does this reduce? So a few head nods. Yep. So 40 and 115, they both end in either a 0 or a 5. So we should be able to divide by 5 on both of them. And so we get a total of 8 out of 23. Or a final answer of 8 out of 23. Again, you could write that as a decimal. You could write it as a percentage as well. It's not going to come out very exact. It's going to be a repeating decimal. So fractions are always exact, and so it's kind of nice to leave it that way. Part B, what is the probability that a member of the art club selected at random is a junior? So in our conditional probability, it would be the probability we select a junior given they're in the art club. So with that formula, we want to find the total number of people in the art club. So we take the total of this column as our denominator, and then the number of juniors would be our numerator. Yeah, so Nadia said, well, there are 58 members of the art club. And how many of those 58 are juniors? Shane?
16.
16. Correct. Excellent. A couple people on the chat with 16 as well. And again, if we can, we want to reduce that. Go ahead, Shane.
We'll divide by 2 to get 8 over 29.
All right. And then we should check, can I reduce 8 over 29? In this case, nope. That is our answer in reduced form. Let's move on to the next. We've got a couple more with this data.
Can you hear me?
Yeah? Go ahead.
My computer's My computer's glitching. Can I turn it off and I'll join right back in.
Yep.
It's a bit glitchy.
All right. Let's see. What is the probability that a member of the drama club is selected? So again, not a conditional probability. Shane,
17 over 150. Or 15, sorry.
so 17 members in the drama club. 115 total. And again, we should check to see if we can reduce that. In this case, we can't. All right, letter D, what is the probability that a member of the drama club is a sophomore? Now we have a conditional probability. So we want the probability that we have a sophomore given they're in the drama club. Okay, so one way to think about this is the first event, what is what is the probability a member of the drama club? So we start with the drama club and then we check, is a sophomore. Yeah, excellent. So in the chat, I had a few answers. So again, the drama club, we take the total of the number of people in the drama club. And our numerator is the number of sophomores. All right, the last one here for this data. What is the probability that a sophomore is a member of the drama club? So there's a little bit different. Here we're going to find the probability that someone is in the drama club given that they are a sophomore. And I'll put the, actually what I'm going to do is I'm going to go to a full screen, make it a little bit easier. So for part D, we had to find the number of people in the drama club and see how many were sophomores. For part E, we're doing it exactly the opposite. How many sophomores are there? And then of those, how many are in the drama club? So how many total sophomores? Shane?
36 total sophomores.
36. And of those 36, how many are in drama? Yep, go ahead, Shane.
3.
3. And then we should check, does that reduce? Go ahead, Shane.
Yes, we can divide it by 3 to get 1/12.
All right. So let's take a look at another set of data. Excuse me. Researchers surveyed students on which superpower they would most like to have. This two-way table displays data for the sample of students who are surveyed. A student will be chosen at random for each of the following questions. So one of the first things that is helpful is finding the totals for each row and each column. So if I find the total for the fly column, what do I get when I take 26 plus 12?
14.
Oh, not 14. Add, don't subtract.
Oh, my bad. That's 38.
38, good. And then what about 12 plus 32? Shane, why don't you hit that one?
44.
44. All right, and how about 10 plus 8?
18.
18. All right, and then I should add the columns as well. So taking the number of males, 26 plus 12 plus 10,
48.
that 8 isn't very good. So let me rewrite that. And while I'm rewriting that, you can add up the total number of females. Shane.
52.
So then how many total students were surveyed?
100.
100, exactly right. All right, so find the probability that a student chose flying as their superpower. What is our total number of students?
100.
100. Of those 100, how many would want flying as their superpower?
38.
38. This one would actually be pretty easy to write as a decimal or as a percent because it's already out of 100. So as a decimal, 0.38, as a percentage, 38%. As a fraction, does it reduce? Shane, what do you get?
Yes, we can divide it by 2 in order to get 14 over 50.
Not 14.
Oh, 19, sorry.
There you go. There you go.
Correct, only glass in the top, the bottom is.
All right, what is the probability that the student selected at random is a male?
$48.
48 out of,
100.
there you go, 48 out of 100. Does that reduce?
Yes.
Okay, to what?
By by 224 over 100 24 over 50.
All right. Does 24 over 50 reduce?
Yeah.
Okay,
By 212 over 25.
and guess what I'm going to ask now? Does 12 over 25 reduce?
6 over. Ah,
12 over 25 does not reduce. All right. Find the probability that the student was male given they chose the ability to fly. Shane, go ahead.
26 over 40.
Not 26 over 40. I like the 26.
Oh, 48.
So the given is flying. How many total people chose flying? Yep. Jane?
38.
Oh, someone beat you. Someone jumped in front. Sorry. 38.
Sorry.
Not a problem. I don't, that's okay. So, and then can I reduce?
Yes.
Yeah. Shane, what does it reduce to?
You divide it by 2 to reduce it to 13 over 19.
There you go. All right. Find the probability, and I'll move the page back up here in just a second, that the student chose to fly given that the student selected was male. I'm going to give you a hint. It's not 13 over 19. So one way that I think about this is I look at that given. They're given that it's a male. So now I only have to worry about the column that are males. So how many total in my probability? Shane,
No, the denominator is 48.
48. And of those 48, how many chose to fly?
26.
26.
Yeah, I was gonna say that.
Can I reduce? Shane,
Yes, you can divide by 2 for 13 over 24.
all right. One more question with this data. Find the probability that a female student chose invisibility as her superpower. So again, in a conditional probability, this would be invisibility given female. Yep, Shane, what did you get?
12 over 44,
Not
or
12.
32 over.
Okay, there you go. There you go. Oh, sorry. 32 is right. 44 is not right. Let's take a look. Now we're talking just the females.
52.
Yeah, so 52 goes in the denominator. Does that reduce?
No. Wait, yeah.
Okay, Makari, what
Can't
can I,
reduce it, right?
what's that?
You can reduce it, right?
Yeah, what can I divide each of those by?
You can divide it by 2.
I can divide both of them by 2. Shane,
You can divide by 2 again to get 8 over 13.
there you go. Excuse me. Ah. All right, so for the try now, what I would like you to do is try these 2 questions. There's the table again, same table that we had for the last 5 questions, and find the 2 probabilities. I'm going to give you a couple of minutes, and if you need to in that time, just get up and stretch your legs or walk around a little bit. Feel free to do that. All right, and I'll put it back so you can see it, the whole table again. And I'm going to turn off my video and my sound. All right. So if we take a look at this problem, or these two problems, I should say. What is the probability that a female student did not choose invisibility or flying? So not invisibility or flying. Given they were female.
I got 18 out of 100 and then 9 out of 50.
Sophie, you are so close. How many total? So the first thing we want to do, the denominator should just be the total number of females, not the total altogether. So how many? So in this case,
52
yeah.
would be the
So
done.
52, and then what would be in the numerator?
18.
Yep. Oh, sorry, 52 in the denominator. What would be in the numerator?
18.
8. 8. And then can that be reduced?
By 2.
Okay. 8 divided by 2 is
4 over 26.
all right. Can that reduce?
Mm-hmm. So you divide it by 2 again.
Yep.
Oh, 2 over 13.
Exactly right. All right, and the last one here. Find the probability that the student chose invisibility as their superpower given they were male. Shane, what do you have?
12 over 48.
Okay. The males total 48. The number that chose invisibility, 12. Does that reduce? Go ahead, Shane, you got it.
You can reduce it by 4
Okay.
to get 3 over 12.
Can that reduce? Go ahead. Shane, go ahead.
You can divide it by 3 to get 1 over 4.
There you go. 1/4. All right. So maybe what I'll do is on the homework, I don't know if I have it set up this way or not, but I might activate the highlighter so that in your table of values, you can highlight and do things like that. If it, that way, it might be helpful. All right. The table shows the results of a class survey. Find the probability that the student did a chore, given they are male, and then find the probability that the student was female, given that they did a chore. And there's actually a letter C. We'll get to that one in a moment. So again, the part after the line, after the given, tells us which row or column that we're concerned with. In this case, it's the male row. And then the part before tells us in that row what column we're concerned with. And in this case, it's they did a chore. So how many males did a chore last night?
7.
7. Out of a total of how many males in the classroom? Shane, go ahead.
15.
Does that reduce? No, it does not. That is our answer. All right. How about the probability that a student is female given they did a chore? So for this one, we're concerned with the yes, they did a chore column and the number of females in that column. Shane, go ahead.
Be 7 over 14.
All right. Does that reduce?
Yes, to 1/2.
Both 7 and 14 are divisible by 7 to give us 1/2. The last one here, what is the probability that a student did a chore given they were female? So again, I'm going to erase here a little bit. So now the given is female. And we want to know the number that did a chore. Shane, go ahead.
7 over 13.
Does that reduce?
No.
All right. So that is what your note check and homework will be on, called conditional probability. There is a warm-up on independent and dependent events and probability. And there is also an exit ticket. So a few things going on today for math class. I will open those up. I've got them unsubmitted right now, or published right now. I'll publish those here in just a second, right after I finish attendance. And then you will have some time to work on those. All right. So again, if you just give me a response, either unmute and let me know, or give me a reaction, that would be fantastic. Riley. Riley Tim.
Here.
All right, thank you, sir. Diovis Williams. Diovis. Kira Peterson.
Here.
All right, thank you. Shane Taylor.
Here.
Excellent. Ari. Sandra Lewis. Ariana. Victor Salvador.
Here.
All right, thank you. Nadia Osman,
Here.
excuse me. All right, thank you. Gia Shell.
Here.
All right, excellent. Kayla.
Here.
Gotcha, Kayla, thank you. Bianca.
Bye.
Bye. All right, gotcha, Bianca. Thank you. Francisco.
Here.
All right, have a good day.
You too.
All right, thank you. James Kelly.
Here.
All right, got it. Kayla Johnson. Kaylee, sorry, Kaylee Johnson.
Here.
Sorry about that. Gotcha, Kaylee, thank you. Sophie Holiday.
Here.
All right. Gotcha, Sophie, thank you. Kevin
Bye.
Hernandez.
Here.
All right, thank you, Kevin, gotcha. Makari.
Here.
All right, gotcha. Thank you. Abdurazak. Abdurazak, I didn't hear
I'm here.
anything. Oh, okay, excellent,
here.
thank you. Jake Carpenter.
Here.
All right, thanks, Jake. Iman.
Here.
All right, gotcha.
Have a good Monday.
Thank you, you as well. Melanie, I didn't call you yet, so I called you now, though. Thank you for putting that in the chat. I appreciate it. Let me know. But I've got you. You're set.
Okay, thank you.
You're welcome.